Dear student, in this video we learn the example on regular falsy method. So regular falsy method is given by x is equal to a into f of b minus b into f of a divided by f of b minus f of a. By using this formula, we solve the example. So here this is the formula. By using this we solve the example. Then the working procedure is that simple is there. First they have given the function. For that function we find one negative root and one positive root by substituting in the given function. Put x equal to 0 1 2 3 or minus 1 minus 2 minus 3 such that we get one negative root or one positive root or one positive root one negative root. By taking that root, then put in the regular falsy method, you get answer. That is answer used in the again regular falsy method. So that is can be called as iteration process. If the two successive iteration are nearly same, then process is stop. That is the root of the equation. So let us solve example. Find the smallest positive root of the equation x square minus log x is equal to 12 by regular falsy method. So here given function is f of x equal to x square minus log x minus 12. The first step is we find one negative root, one positive root by substituting x equal to 0, 1, 2, 3 or minus 1, minus 2, minus 3. It is trial and error method. So put x equal to 1, we get minus 11. Put x equal to 2 here, we get f of 12, f of 2 is equal to minus 8.69. Put x equal to 3 here, f of 3 is equal to minus 4.0986. Put x is equal to 4 here, we get f of 4 is equal to 2.6137. So by substituting 3 it is negative root, by substituting 4 we get the positive root. Therefore here we get alternative negative and positive root. Therefore a real root lies in 3 and 4. By taking these 2 points, if you solve the regular falsy method, we get answer, but it will be take the more number of iteration because the distance between 3 and 4 is 1. If you solve by taking this point, you get answer, but it will take time. To avoid the number of iteration more, we take in between these 2 points such that if the distance between 2 points is less, the number of iteration will be less. For that, we check in between 3 and 4 again on negative root or on positive root by substituting x equal to here 3.1, 3.4, 3.5, 3.6 like that. So you check trial and error method. Again you find one negative root and one positive root. So by substituting x equal to 3.6 here, we get f of 3.6 is equal to minus 0.3209. Put x equal to 3.7, we get plus 0.387. Therefore the root lies between 3.6 and 3.7. Now see the distance. The distance is 0.1. You get in 2 or 3 iteration answer. If you take these, you get answer, but it will take 7 and 8 iteration. So that is the difference. So let us take these 2 points and solve. For the first iteration, a is 3.6, f of 3.6 is already calculated. This is minus 0.3209. B is 3.7, f of 3.7 is 0.3817 calculated. Then put a, f of a, b, f of b in the regular falsy method. That is x1 is equal to a into f of b minus b into f of a divided by f of b minus f of a. Here x1 denotes the first iteration. Then put a value 3.6, b value 0.3817 minus b is 3.7, f of a is minus 0.3209 divided by 0.3817 plus 0.3209. On simplification we get x1 is equal to 3.645. Therefore x1 is equal to 3.6457. Next solve the second iteration. So put x1 value in given f of x. So f of 3.6457 is minus 0.00242. So it is negative root. Then for the second iteration also we require one positive root and one negative root. Here Negative root can be obtained by taking the answer of first iteration. Then the positive root can be taken from the first iteration, that is b is equal to 3.7 is the positive in the first iteration. So a is equal to 3.6457, b is equal to 3.7, then f of 3.6457 answer is negative, f of 3.7 is positive. Then put in the regular falsy formula, that is x2 is equal to a into f of b minus b into f of a divided by f of b minus f of a. Put a value 3.6457 into f of b 0.3817 minus b value 3.7, f of a value minus 0.00242 divided by 0.3817 plus 0.00242. This minus plus this. Then on simplify we get x2 values 3.64042. Now see or compare with the first iteration answer. Here the first iteration answer is 3.6457. Then the second iteration answer is 3.6460. Up to 0.64 second decimal answer is same. It is 5 is there, it is 6 is there. So the difference is 0.001. So first and second iteration is same, nearly same. Therefore the required root correct to 3 decimal places is 3.646. If the first iteration and second iteration is not nearly same, then find one more iteration, that is third iteration, then compare with the second iteration. Here first and second iteration nearly same, therefore the root of the equation is 3.646. So this is a solution for regular false method. So let us solve one more example. Find the root of the equation x into e raised to x minus cos x equal to 0 by the method of falsy position, or it is called as regular falsy position. So first we write f of x equal to x into e raised to x minus cos x. Put here x equal to 0, 1, 2, 3 or minus 1, minus 2, minus 3, etc. Then find one negative root and one positive root. So put x equal to 0, we get minus 1. Put x equal to 1, we get positive root, that is 2.178. Therefore root lies between 0 and 1. Therefore real root lies in 0 and 1. By taking 0 and 1 we get answer, but it will take the iteration more to reduce that. So in between 0 and 1 we check again one positive root and one negative root, or one negative root and positive root. By substituting again 0.1, 0.2, 0.5, 0.7 randomly, put x equal to 0.5, we get minus 0.0532, it is negative root. Put x equal to 0.6, we get plus 0.2679. So it is negative root, it is positive root. So the root lies in 0.5 and 0.6. Therefore root lies between 0.5 and 0.6. Now see the distance, it is 0.1. So in the 2 or 3 iteration you get the answer. So let us solve by iteration process. First iteration, a will be always take negative 0.5, b is take positive 0.6, f of a already calculated here, that is f of I minus 0.0532, f of 0.6 we get 0.2679. Then put in the regular falsy formula, that is x1 is equal to a into f of b minus b into f of a divided by f of b minus f of a. So all the values are here. Put in the formula a f of b minus b f of a divided by f of b minus f of a. On simplify we get 0.5166. x1 is equal to 0.5166. It is a root. It will be used for the second iteration. Then second iteration. So put the x1 is equal to 0.516 in given f of x. We get f of 5166 is equal to minus 0.0035. It is a negative root. So if it is negative, then we require one positive root, so that it can be taken from the previous iteration. That is, in the previous iteration the 0.6 is the positive root, so we take positive as a 0.6. So a equal to 0.5166, b is equal to 0.6. It is a negative root, it is a positive root. Suppose here you get the positive root, means you take the negative root from the first iteration. So this is a method. Then Here a is 0.5166, f of a will be the minus 0.0035, b will be the 0.6, f of b will be the 0.267. So put all the four value in the regular falsy formula, that is x2 is equal to a into f of b minus b into f of a divided by f of b minus f of a. So put a value 0.5166, b value 0.2679 minus b value 0.6, a value minus 0.0035 divided by f of b 0.2679 minus of 0.0035. On simplification, we get x2 value is 0.177. So this compare with the first answer. The first answer is 0.5166. It will be 0.5177. So distance is, it is nearly 10 difference is there. So it is distance between x2 and x2 is the 0, 0, 10 is there. So let us solve one more iteration. So try to make the distance between the 2.2 iteration answer will be the less. So for that, solve one more iteration. Already you know the iteration means if the second and third or if the consecutive iteration nearly same, then it will be the taken the answer. So third iteration, put x2 value in given f of x, that is 0.5177. We get minus 0.00017. It is a negative root. So in the third iteration, we require one positive root and one negative root. Again here we get negative root. In the second iteration, the positive root will be the 0.6. It is a 0.6. So for the third iteration, you take this is also 0.6. A is equal to negative root, that is 0.5177. F of a will be the minus 0.00017. B is 0.6. F of b is already calculated 0.2679. So put these four value in the regular falsy method or falsy position method, that is x3 is equal to f a into f of b minus b into f of a divided by f of b minus f of a. Here 3 denotes the third iteration. So put value a value f of b minus b f of a divided by f of b minus f of a. On simplify, we get 0.5178. The second iteration is 0.5177. The third iteration is 0.5178. So the distance is very small, that is 0.0001. Therefore x2 and x3 are nearly same. Therefore the smallest root or required root is 0.5178. So let us solve one more example. Use regular falsy method to find real root of the equation x cube minus 2x minus 5 equal to 0. Correct 2 3 decimal places. So here also by using regular falsy solve, but after the decimal the 3 point will be same. Up to that we have to solve. If they have given 3 iteration, up to 3 iteration we have to solve. If they have given 4 iteration, we have to solve up to 4 iteration. If they have not mentioned means if the two consecutive answer is same, up to that we have to solve. So let us solve by using regular falsy method. So let f of x equal to x cube minus 2x minus 5. So put x equal to 0 1 2 3 etc minus 1 minus 2 minus 3 etc, such that we find one negative root and positive root. Put x equal to 0, we get minus 5. Then put x equal to 1, we get minus 6. Put x equal to 2, we get minus 1. Put x equal to 3, we get 16. So here by substituting 2 we get negative, by substituting 3 we get positive root. Therefore the real root lies in 2 and 3. So already in the previous example I have told, if the distance is more, the number of iteration will be more. So avoid that. We check in between 2 and 3, again one positive root and one negative root, such that distance between the 2 point is less. So put x equal to 2.1 here, we get 0.061. So that is positive. By substituting 2 we get minus 1. By substituting 2.1 we get 0.061. Now distance is 2 and 2.1 is 0.1. So the number of iteration will be less. Therefore root lies between 2 and 2.1. For the first iteration, a is equal to 2, f of a is equal to minus 1, b is equal to 2.1, f of b is equal to 0.061. So put in the regular falsy formula, that is x equal to a into f of b minus b into f of a divided by f of b minus f of a. So first iteration is denoted as x1. So put a to f of b is 0.061 plus b 2.1 plus, because this minus and this minus plus 2.1 into 1 divided by f of b is 0.061 minus of minus 1, so that become plus 1. On simplify we get x1 value is 2.0942. Then put x1 value in given f of x for the second iteration. So check whether it is negative or positive. So put x1 is equal to 2.094 in the given f of x. F of 2.0942 we get minus 0.03926. So it is a negative root. So in the second iteration we required one positive root and one negative root. By putting the x equal to 2.094, it is negative. We take the positive iteration from the previous iteration, so that is 2.1 is the positive. So here also we take for the second iteration 2.1 is the positive root. So a is 2.0942, f of a will be the 0.00392, b will be the 2.1, then f of 2.1 is 0.061. Then put in the regular falsy formula, that is x2 second iteration, x2 into second iteration, a into f of b minus b into f of a. Already you know your formula here, the a into f of b minus b into f of a divided by f of b minus f of a. So put here we get x2 values 2.09455. So in the question they have given up to 3 decimal place, the answer will be same. The first answer is 2.0942, the 3 decimal will be the after the point 094. Then in the second iteration answer will be 2.0945, then the after the decimal 3 point will be the 094. So 2.094, 2.094, first and second iteration answer will be same. Therefore the required approximate root correct to the 3 decimal place is 2.094, or we take the next point, that is 2.0945 means 2.095. Either you write 2.094 or we write 2.095. So it is the regular falsy method. So let us take one more example, that is find the real root of the equation cos x equal to 3x minus 1. Correct to 3 decimal places by using the regular falsy method. So here given f of x equal to cos x plus 1 minus 3x. If the given function in terms of trigonometric, so we convert calci in terms of radian, then solve. Trigonometric means if the function contain cos, sin, tan, then convert calci in terms of radian, then solve. So put x equal to 0, we get 2, that is positive. Put x equal to 1, we get minus 1.46. So convert calci in terms of radian before solving this. Then here by putting 0 we get positive, by substituting 1 we get negative. Therefore root lies between 0 and 1. So here if you take 0 and 1 you get answer, but the process will be lengthy. To avoid that, we check in between 0 and 1 negative root and one positive root. For that you put randomly 0.1, 0.4, 0.5 in it, such that we get one negative root and a positive root, and the distance between 2 points is less. So here we are substituting x equal to 0.6, we get 0.0253, that is positive root. By substituting x equal to 0.7, given f of x, we get negative root, that is minus 0.3352. So the root lies between 0.6 and 0.7. Then for the first iteration, a is equal to 0.6, f of a is equal to 0.0253, b equal to 0.7, f of b equal to minus 0.3352. So put these four values in the regular falsy formula, that is x1 is equal to a into f of b minus b into f of a divided by f of b minus f of a. Then put the A value f.6, f of B value is minus 0.3352 minus B value is 0.7, f of A value is 0.0253, f of B minus of 0.3352 minus f of A value is 0.0253. So on simplify we get x1 is equal to 0.607. So up to 3 decimal place means after the point you write at least the 3 point. Then for the second iteration put x1 value in given f of x, we get f of 0.607 is a 0.00036, it is a positive, therefore the root lies is 0.607 and 0.7. So it is a positive means you take the negative root from the previous iteration in the process you know. So here in the previous iteration the negative root is 0.7, so it is a positive root 0.607, the negative root is 0.7. Therefore A equal to 0.607, B equal to 0.7. Then f of A is already calculated, f of B is calculated. Then put in the regular falsy formula, that is x2 is equal to A into f of B minus B into f of A divided by f of B minus f of A. So put A value f of B minus B f of A, f of B minus f of A. On solving we get x2 is equal to 0.607. Here you see x1 is 0.607, x2 is 0.607. x1 and x2 both are same up to 3 decimal places, therefore the real root correct to 3 decimal places 0.607. If the trigonometry is there, then convert the calci in terms of radian. You have to remember that. So in the next question they have given already root. Show that a real root of equation tan hyperbolic x plus tan x equal to 0 lies between 2 and 3. Then apply the regular falsy method to find third approximation. So in the question they have given f of x, already they have given the one negative root and positive root. Then by using these two root up to third approximation, third iteration, we have to solve the example. Already I have told in the previous example, if it is trigonometry is there, we convert in terms of radian. So given f of x equal to tan hyperbolic x plus tan x, in radian you measure, put x equal to 2, we get minus 1.221, that is negative root. Put x equal to 3, we get 0.8525, it is positive. Therefore the root lies between 2 and 3. So here already they have mentioned root lies between 2 and 3 means we cannot check in between the roots. If they have not given, then we check in between the roots. Therefore the root lies between 2 and 3. So if they have given directly one negative root and positive root, we cannot check in between the root. So the first approximation A is equal to 2, B is equal to 3, then f of A is equal to minus 1.221, f of B equal to 0.8525. So put these values in the regular falsy formula, that is x1 is equal to A into f of B minus B into f of A divided by f of B minus f of A. So x1 denotes the first approximation. Put A value f of B, B value f of B divided by f of B minus f of A. On simplification we get 2.59. The root of the first iteration is 2.59. So for the second iteration, put the f of 2.5 in the given f of x, we get that is 0.3735. So we get the positive root by substituting x equal to 2.59. Then we take the one negative root from the previous iteration. So that is in the previous iteration the negative root is 2. So second iteration A is equal to 2, f of A is minus 1.221, B is equal to 2.59, f of B equal to 0.3735. So put in the regular falsy formula, that is x2 is equal to A into f of B minus B into f of A divided by f of B minus f of A. So A into f of B minus B into f of A divided by f of B minus f of A, we get 2.4518. So up to third approximation we have to solve this. Then put x value 2.4518 in f of x, we get 0.1603. It is also positive root. For the third iteration, we require a negative root and one positive root. So it is a positive root, and then the negative root from the previous iteration is, so that is 2. Therefore, for the third iteration, a will be the negative, that is 2. B will be positive, that is 2.4518. Then it is f of a minus 1.221. F of b is 0.1603. So put in the regular Falsy formula, x3 is equal to a into f of b minus b into f of a divided by f of b minus f of a. We get 2 into 0.1603 plus 2.4518 into 1.221 divided by 0.1603 plus 1.221. On simplify, we get 2.3994. So here they have asked up to third approximation or iteration. So the required root for the third approximation is 2.3994. So it is the regular Falsy method. In the next video, we learn the last concept of model is Newton-Raphson formula or Newton-Raphson method. Thank you.